Yes, sir. We are live now.
Yes, Amir. Yeah, I can see a few attendees. So please let me welcome you all, and kindly be standby. We will be starting the proceedings in another few minutes. Yeah. Good afternoon to all of you. I can see some participants have joined in already. So I'll just request them to be on standby, and we'll be starting the proceedings in another 2 minutes. Kindly be on standby. Okay, so Okay, so welcome everybody. I hope you can hear me nicely. So welcome to this INA technical session, session number 11. I can see we have close to now almost 25 participants. I will say thanks for giving this time on this Saturday afternoon. I know it's a time to relax. So thanks to all of you for taking out time from your schedule and giving to this technical enrichment session. So without further ado, let me introduce session chair, Mr. Ashwini Kumar. Mr. Kumar is a IIT Kharagpur Naval architect from the batch of 1981. And he has also done various management courses in the most eminent institutes in India and abroad, which includes Jamnalal Bajaj Institute, IIM Ahmedabad, and INSEAD in France. So having started his career in ship design and construction with Majgaon Dock Limited in Mumbai in 1981, he moved on to marketing and execution of projects in 1985 with Chaugle and Co. Later, he joined Larsen and Tourbo in April 1989 and was a key member of the upstream hydrocarbon team since its inception and all through its growth phase till 2014. He has managed the execution of several projects on turnkey basis in India, Africa, and Middle East, involving design, procurement, construction, installation, and commissioning of offshore platforms and pipelines, and has overseen upstream business units of L&T Hydrocarbon Engineering. In May 2014, Mr. Ashwini Kumar joined IoT Infrastructure and Energy Services Limited and served as Group President and Head of EPC Business till 2017. In July 2017, he joined AFCONS Infrastructure Limited and currently holds the oil and gas business unit. So he has more than 40 years of experience in the oil and gas EPC industry. With this, kindly allow me to hand the floor to Mr. Kumar, who shall take the session forward. Over to you, Mr. Kumar.
Thank you so much, Rajneesh. Thank you very much. Ladies and gentlemen, good afternoon. Welcome to what promises to be a very interesting session, possibly the first technical session of 2022, which is going to be delivered by Shrivardhaan Jois, Shri as we very fondly know him. It is before we start the program, I would like to say it is my proud privilege and an honor to introduce the chief guest for today's session, Mr. M.V. Ramamurthy. The first couple of times when I met Mr. Ramamurthy, I think it was more than 40 years ago, he said it's very, very easy to remember my initials. M.V. Ramamurthy is Motor Vessel Ramamurthy. So from that point of view, right in the beginning, his name is completely interlinked with the marine industry. Mr. Ramamurthy graduated in mechanical engineering in 1967, so that is 55 solid years of contribution to the marine industry, and a true doyen of the industry is with us today as chief guest. He served initially in Shipping Corporation of India and rose to be to the position of chief engineer, and then he took a shore-based position as technical superintendent. After that, he had a short stint in Larsen and Tourbo when L&T moved into shipping operations. And after that, he moved into Reliance Industries. I remember those days when Reliance was starting up a very sensitive ethylene transportation and program and transshipping from Hazira Outer to Hazira Inner, and he was heading that very, very sensitive operation, and I had the privilege to work closely with him those days when I was in Larsen and Tourbo. So most of his career, he has been, the last 30 years of his career, he has been with Reliance and retired recently as President Shipping. He is a fellow and past president of the Institution of Marine Engineers and also a fellow and honorary fellow of the Company of Master Mariners of India. He has been supporting IRS as chairman of IRS Technical Committee for many decades and also as a director of IRS. And he has been supporting the Indian National Shipowners Association as well as director. He has shared his knowledge and experience with many, many maritime training institutes and academic institutions. And his contribution to the marine maritime industry has been truly immense and noteworthy. So, with these few words, it's my privilege and honor to welcome you to today's session, and thank you so much for accepting to be our chief guest for today.
Thank you, Mr. Kumar. So nice of you to give that nice words. Thank you so much.
It's a privilege to have you with us. I have also had the pleasure and privilege of working with Sri for many years when I was in Larsen and Tourbo. Sri graduated in mechanical engineering and went on to do his master's as well in mechanical engineering in the US. And after he returned to India and spent a short term service with another company as a CAD engineer, then he moved into Larsen and Tourbo, I think sometime 2004 or 2005. And he moved from mechanical engineering to naval architecture and offshore in a very, very big way. And I think his training and experience in the academic world in finite element analysis that proved to be a very good support for him and contribution to the engineering effort in ocean engineering and L&T. So he started with, if I recall, quite a lot of work in stability analysis and motion analysis of structures and jack-up rigs and platforms and structural analysis. And recently, he has been also taking up the role of managing engineering as an engineering manager and guiding the entire engineering program for process platforms, jack-up drilling rigs, modifications, and as well as other floating structures. So Sri brings with him a wealth of experience in analytical engineering and a very, I would say, rigorous amount of finite element analysis to the industry. And we are going to have a very, very interesting session from Sri in an industry which is a sunrise industry and something which I believe India has a very, very, very long distance to go as compared to some other countries who have made enormous progress in that industry. And we have to catch up really big time in offshore wind energy harnessing. So with that, I would like to invite Shrivardhaan to start his presentation for today's session. Sri, the floor is yours. Start up, please.
Thank you very much, Ashwini Kumar sir. It's a great pleasure to see you again and hear you again after all these years. And just to give a brief, I have worked with Ashwini Kumar sir immediately after I joined L&T in the design, development, and construction of LTS 3000, the heavy lift vessel, which L&T owns currently. And it was a great experience working with sir under his guidance and under his mentorship. And that's where I would say I got the whole flavor for naval architecture and developed into that particular into that area. Thank you very much, sir, for the warm welcome and kind words. I saw the title slide and it says expert presentation by Shrivardhaan Jois. I don't think or I don't feel that I'm an expert in this particular area. It's a as Ashwini Kumar sir said, it's a sunrise industry, and everybody here is learning as we go along, except maybe for the Europeans who are way ahead in this area right now. So with that, I would start my presentation. I hope I will be able to do some justice to the topic, because this is not exactly the offshore wind farm overview, but it's more in terms of the installation related activities that we will be focusing on. So today's topic is basically offshore wind farm development with focus on the installation and construction vessels, which play a key role in this whole sector. Basic agenda would be to give a brief overview on the market trends. What is the wind farm like? What are the general components of a wind farm? What are the drivers for installation vessels? What kind of transportation installation philosophy do you adopt for these structures? Some of the marine operation challenges, philosophy, and finally, summary and conclusion. To start off with, I will start off with a safety movement.
Each of us can make a difference by actively caring every day. Together, we can ensure that nobody gets hurt.
So to start off the presentation, as we are aware, with the recent United Nations climate conference, there have been a lot of countries who have adopted the net zero emissions. Majority of them have identified to achieve net zero emissions by 2050. To achieve that, 82% of the electricity has to come from renewable sources, and 33% of that from wind, of which 11% actually would come from fixed structures and 2% from floating offshore wind platforms. Currently, the offshore wind capacity that is as installed as of 2020 is 35 gigawatt. And if you have to achieve net zero emissions and 1.5 degree centigrade targets, then we have to reach 270 gigawatts by 2030 and 2000 gigawatts of offshore wind capacity by 2050. Currently, the offshore wind market, as we are aware, is driven by Europe and China. And slowly, US, Japan, and Taiwan are picking up also. In India, right now, till 2019, we had the target of 5 gigawatt offshore wind plants by 2022 and 30 gigawatt by 2030. But due to the COVID pandemic, a lot of it has got shifted. The global offshore energy market is expected to reach close to $57 billion by 2026 at a growth rate of 12.3%. Earlier, it was growing at close to 15 to 17%, but in the last 2 years due to the COVID pandemic, the growth rate has come down a little, but still it is in the 12.5% range. Most of the bottom fixed wind projects have a levelized cost of energy at $50 per megawatt hour, whereas the floating wind farms are close to 200 megawatt per hour. And this is where the hurdle lies for the floating wind platforms to break through. If they are able to, over a period of time, bring down that cost of energy, automatically they become more useful and will be driven in the next phase of wind energy. This requirements of reaching 270 gigawatt by 2030 and 2000 gigawatts by 2050 uh, lead to a lot of capacity constraints, especially in the fabrication and the installation area. Today, the major focus is on improving or increasing the size of the turbines to reduce the number of turbines per wind farm. Thereby, the the load on the requirement of higher capacity installation vessels is increasing, and there is a huge shortfall which is seen right now and is anticipated for the next 4 to 5 years also. This is just a typical offshore wind farm, uh, basic processes and supply chain components. So, as a developer, you start with your overall wind capacity of a particular area. You do your surveys in terms of the metocean, geophysical, geotechnical, ornithological, and mammal survey, because especially in the European and US regions, a lot of focus is on the environmental impact. And many of the wind farm projects have been stalled or put on hold due to environmental issues. Many of the countries have strict guidelines and regulations to ensure these are taken care of at the start of the development phase itself. And uh, rules and regulations related to the migratory birds routes with respect to the mammals, noise mitigations to during piling. All these are a part of the regulatory norms of individual countries for the offshore field development. We have the facilities or equipments like foundation installation vessels. You have your cable laying vessels. You have your trenching vessels, ROVs. You have substation installation, heavy lift vessels. You do have O&M related specific equipments and vessels. You have your unmanned drones, helicopters for transfer of personnel. So this is the overall to give an idea of how the different processes work across the wind farm. This is a little, I would say, dense slide because it packs a lot of information. Uh, what you see here is basically you have your turbines, offshore wind turbines. Currently, it is fixed right now. What I'm showing here, which generate power at 33 or to 66 kilovolt. They are turbines of 3 megawatt to upcoming 12 megawatt turbines each. And so on a average wind farm, you would have close to 100, 150, 200, depending on the size of development. So to support these wind turbines, you have either monopiles or jackets. These jackets are very, I would say, not as heavy or as complex as a offshore oil and gas jacket. These are in the range of 500 to 1500 metric tons, and monopiles are having a general diameter of 6 to 9 meters and weights ranging from 600 to about 1,000 on the higher side. The turbine rotor dia vary from 128 meters to 220 meters depending on the capacity. So for a 12 megawatt, the rotor dia would be 220 meters. For the 3 megawatt, it would be 128. The weights range from rotor weight range from 110 metric tons to 250 metric tons. The nacelle weighs around 290 to 800. So the 12 megawatt turbine nacelle weighs close to 800 metric tons. The 8 megawatt or 9 megawatt turbine nacelle size would be about 21 meters by 9 meters by 9 meters. The tower weighs close to 650 metric tons to 850 metric tons. The height varies from 80 to 150 meters. So you can imagine the capacities requirement from the installation perspective, handling perspective, transportation perspective. So the power from these turbines is then through array cables goes to either a HVAC, that is high voltage AC substation for stepping up the voltage, and or it goes to a HVDC in case the wind farm is beyond 80 kilometers away from shore. The HVDC requirement comes up to reduce the amount of losses that happen while traveling large distances. So you have the HVAC substation platforms which step up the voltage from 33 or 66 kilovolt to 155 or 220 kilovolt. These are pretty similar to our, to give an idea, offshore wellhead platform where the top sides range from 2100 to 4500 metric tons. Sorry. And jacket weigh around 1400 to 2000 metric tons. And it's a piled structure, so the piles weigh around 800 to 1200 metric ton. The HVDC platforms, on the other hand, are on the heavier side, and they are close to process platform topside weight. So they weigh close to between 10,000 to 15,000 metric tons with a jacket weight of 7,000 metric tons. And they step up the voltage from 155 kilovolt to 320 kilovolt. So typical offshore vessels that we generally see in a wind farm area are the wind turbine installation vessels, which are basically self-elevating and jack-up kind of a concept, but more ship-shaped, which also has fast jacking capability because they have to install jack-up, jack-down on a very frequent basis. Generally, the turnaround time for wind turbine installation is close to 1.5 to 2 days. And they also have huge crane. They need to have a huge crane capacity and accommodation. So they, in that sense, they are not similar to the oil and gas jackup rigs. You also have the foundation installation vessels, which are which might not be ship shape. They might be heavy lift vessels also, floating vessels, and they install your monopiles or jacket depending on the substructure design. Then you have the cable laying vessels. These are utilized to install both the array cables as well as the export cables. Now, the only difference is the export cable installation vessels would have a larger carousel compared to the array cabling vessels. Generally, these vessels are equipped with their own burial and trenching equipment like cable plow, ROVs, etc. Then you have the service vessels, which provide accommodation and gangway access for O&M personnel. They are equipped. It's like the hookup vessels of oil and gas with large cranes and heave compensated gangways. The major drivers for the installation vessels are like, what are we installing? Are we installing the turbines? Are we installing the foundation? Are we installing the cables? And what is the size that we need to handle? How much is the weight that we need to lift? And how do you have to hold it? Now, holding is critical because if you are installing turbine nacelle or turbine blades, then accuracy tolerances have to be very fine and need to be maintained precisely for the bolts to be engaged, and people are working there, tightening the bolts, torquing the bolts. So safety is of prime importance, and hence the requirement of understanding the holding philosophies also. The usual suspects of water depth, metocean conditions, geotechnical, geophysical data are the key drivers anyways. Also, the aspect that comes to with respect to wind farm installation is the distance to travel, or if there is any limitation on draft, beam, or height. Now, this last point is related to the infrastructure that you have for the infrastructure in terms of ports or vessels which are required to transport or transfer this wind turbine equipment or offshore structures. So if you are looking at a transit using the wind turbine installation vessel itself, then the distance to the port, turnaround times, all that matter. If you're looking at a certain port with a specific restriction on beam width or draft limitation, that decides the vessel design also. Now, if you see the photograph, it's more of a layout of Lillgrund offshore wind park, and if you see a particular area which does not have any turbines, and this primarily is because the water depth in that particular area was very shallow, and the installation vessel could not approach that area or work in that particular area. Hence, the wind turbines could not be installed. So that is the kind of impact you have if you do not, if you're not aware of the uh, wind farm requirements and the vessel you are bringing into operating that area. This is a typical offshore wind turbine installation vessel. So this one is a six-legged. You have four-legged also, depends on the deck space requirement. So you have the key features. You have a main crane with a lift capacity varying from anywhere between 500 tons to nowadays requirement of 3,000 tons. You have accommodation. You have DP thrusters. Most of these vessels have to be DP2 to achieve positioning and keep operating in even if systems are down. So DP is a major requirement. Otherwise, you'll be working with a lot of DP tugs, DP barges, and issues with respect to parallel SIMOPS in that particular area. You have close to um, 50 jackups in operation and four under construction in Europe. You have close to 32 heavy lift vessels in Europe versus four under construction. The next largest is 25 in China. As you can see here, Europe and China, as I pointed out earlier, are the major drivers for the offshore wind farm industry right now. The issue with jackups or installation vessels in North America is related to a regulatory requirement known as Jones Act. Here, there is a mandatory requirement that any installation vessel or any vessel which is operating between 2 points within US has to be built in US, and the whole activity has to happen within US. So that is one of the major bottlenecks with respect to the wind farm industry in US. So to circumvent that, there are certain aspects which the developers are looking at, which I'll talk about as I go ahead. This is a overview of the way these installation vessels have evolved. So we are at the current fourth generation vessels. These are primarily driven by the wind turbine size, which we are planning of installing. As you can see, they have changed from 500-ton crane capacity to right now 3,000-ton capacity, and variable deck load of 2,000 tons to close to now 16,000 tons. 15 megawatt is yet to come right now, but GE has already bought in a 12 megawatt wind turbine. So the drivers for wind turbine installation vessels are the turbines which are growing taller and heavier. As I had earlier mentioned also, the rotor dias have gone up from 128 to 220, from 110 metric ton to 250 metric ton, 290 to 800 metric ton. On the right here, you can see I have listed the parameters for a 9 megawatt turbine, which is 175 meters rotor diameter. The blade weight is 40 tons. So there are like three, so it becomes 120 tons plus the nacelle of 450 tons. You have the tower length of 994 with a tower weight of 500 metric tons. So this, and if you see here, you have two sections. So basically, this total length is divided into two of 47 meters each, and the installation is thought of in that sense, two section installation. This is the current status of the capabilities of the offshore wind turbine installation vessels to handle this 12 megawatt turbine in water depth of 50 meters. If you see, you have only a few vessels like Pacific, Osprey, uh, Cilia, Innovation, who have a certain carrying capacity of 1075, 1500 metric tons to handle these wind turbines. The existing vessels like Sea Installer, Sea Challenger are incapable because of their restrictions on the water depth. If the installation happens at a lower water depth, then it might be possible to utilize them, especially IOLS or Voleomon, which have got 1600 to 1500 metric ton capacity. Currently, few developers are building new vessels with higher capacities, especially if you see you have the Charybdis in the US for meeting the Jones Act. It's a 2200 metric ton crane capacity vessel with a 161 meter hook height. Similarly, you have Voltaire from Jean de Null Group, which is 3000 metric ton with 130 meter to handle a little higher wind turbine capacity. From a turbine installation design perspective, generally the design is based on the 50-year storm condition of the region, whether it is Europe, China, US, based on whatever the classification society requirements. You have the geotechnical conditions, so where the SNAME guidelines and class guidelines apply. Then the turbine requirements, like towers which are up to 500 metric ton weight, lengths of up to 94, 150 meters, dia up to 7 meters. Requirement to load these towers and the blades on the deck, so large deck capacity requirements. As I said, nacelles as large as 21 by 9 by 10 by 10 to be taken along, weighing up to 450 metric ton. And these have to be lifted close to 117 meters above sea level and held in place, so while being bolted. So precision of holding, taking care of the motions that occur, especially you have, if you see, the wind turbine is a tall cantilever with a large lump mass at the top, and the jackup is a similar thing, which is on four legs with a crane holding onto some heavy structure. So these two would tend to move with the environment. So trying to design these structures away from the natural periods occurring in that area to reduce the amount of motion and to get a better tolerance and better constructability. These are some of the typical offshore foundation installation vessels. So earlier days, you started with a dumb barge with a crane on top, which later we move towards shear leg cranes, then non-propelled jack-up rigs, heavy lift vessels, semi-submersible heavy lift vessels. Today, the jackets as well as the monopiles are sometimes installed using self-propelled jack-up also. That is, you install both the wind turbine as well as the foundation with the same vessel. The foundation installation vessels are driven by the concepts. So you have gravity foundation concept, which is generally utilized for water depths less than 15 meters. Steel structures, you have monopiles varying in diameter from 6 to 9 meters and even going bigger nowadays in water depths, preferably less than 30 meters, but we have seen them move towards 40-45 meters also. And then you have the jacket structures and the tripod structures going up to 60 to 70 meters water depth. Jacket structures are a known phenomena for the oil and gas industry compared to the monopiles and the tripod. The general weights of monopile, as I was informing earlier, range from 600 to 750 metric tons. Similarly, jackets which are in the 30 to 50 meter water depth are as high as 900 to 1000 metric tons. Going beyond, we have the floating structures, generally which are either the semi-submersible type or the spar type, depending on the design proposed for that particular area. This is just a small flow chart of the design considerations to give an idea of what kind of things to look at. Like if I'm looking at a water depth of something greater than 20 meter, do I go for a monopile or do I go for a jacket? So if I'm not more than 20 meters, then I go towards monopiles. And if it is yes, that I proceed still with monopiles depending on the geotechnical seabed criteria, because sometimes it is possible that you have rock in that particular area. So you do not prefer a monopile, you might go for a jacket. So if you're going still with a monopile, then you can float it out, you can transport it on your feeder barges, you can take it on your installation vessels and install it using a floating crane. If you're going with a jacket, either are we going with pin piles or without pin piles? Pin piles, if we are not going with, then we have to do a lot of site preparation like rock dumping, jetting, leveling of the area. Whereas if you go with pin piles, then you can straight away go ahead with the installation of the jackets. So coming to whether jackets are more than 1100 tons, if they are more than 1100 tons, you have to use a heavy lift vessel, floating crane. If not, you could use a wind turbine installation vessel to handle these. So this is basically a kind of a flowchart that could be looked at for the different design options that we are looking for. Coming to the transportation and installation philosophy, generally there are two types of strategies. One is the transit strategy, where you have the main wind turbine installation vessel itself carrying the different parts and material out of the ports and taking it to the site where they do the installation. Once you do a set of wind turbines, then you come back again and do the next load. The other strategy is to go for a feeder strategy, where it's the wind turbine vessel, installation vessel stays in the field like a oil and gas installation vessel, and you have feeder barges which ferry parts from the port to the wind farm site. Now these feeder barges are smaller units with no crane, but the which strategy to adopt depends on the cost benefit analysis, like I have indicated here. So it's like how far is the wind farm from the infrastructure, what is the transit speed of your vessel, what is the capacity of your vessel, what are the day rates, technical viability of the feeder barge, whether it is possible to transport it using a feeder barge, tidal constraints, water depth issues, quayside limitations, port limitations. all these aspects are play a part in deciding which strategy to go for. Now, as I was discussing earlier, US has got this particular issue with respect to the Jones Act. So many of the developers are using the feeder strategy, where they have feeder barges made in US, transporting these equipments and parts to the installation vessel, which is stationed at the site. And these installation vessels could be from Europe or any other place. So this allows them to get away with that particular regulation of having a vessel which is operating between 2 points within US to be built in. And that's what you see on the right here. So this is a feeder barge with the turbine blades on it. And this is the installation vessel. Right now, this is the nacelle part. So you would be connecting the blades to this particular area. This is the deck layout for a large installation vessel. You can see it's carrying 4 turbines. With the feeder option, the number of turbines that you can carry is lower. So that's how you have to look at in terms of, if do you want to spend money on the feeder barges, or do you want to take it on a single large installation vessel. Now, generally the day rates of these installation vessels are close to 200 to 250 $1,000 per day. Whereas for the feeder barges, it is around 80,000 to $85,000 per day. So those are the cost benefit analysis that a developer has to undertake to decide on a strategy. This again is a small flowchart to consider what kind of transportation strategy you can undertake. So if you're going for a feeder option, whether you're going to be fed by feeder barges, whether they be moored or not. If they're moored, then you will have to have anchor handling vessels, you would have to have tug, which is DP, all those other marine spread associated with it. If not, you could fit a DP system. Now, the DP system, either you can fit it at yard itself, or else you have a portable DP built into that vessel by the project as a part of the operating cost. So again, it's more in terms of the cost part of the project. How do you want to undertake this? But it is generally preferred to install the DP at the yard itself, so that you are able to recover it over a period of time quickly, instead of doing it project specific. If you're not going for the feeder option, then you go for a self-propelled installation vessel. The issue will be with the existing ports, where you might have beam restrictions or variable load capacity requirements. These are some of the jacket foundation installation methodology. So here it is a pin pile installation philosophy, where you have a template in place, and through the template you install the pin piles, you retrieve the template, and you have your dimensional checks, dimensional tolerances checks. You have your post-construction survey to see the accuracy of installation. Then you have your jacket brought along. Now these two can be planned in different seasons. The advantage of having a pin pile installation philosophy is you can do it at different times based on the weather window. So that helps. You can install the pin piles, and next season you could install the jacket. So you have the jacket on board the vessel being lifted off, lowered, and stabbed onto the pin piles, then grouted, and then you have your final survey to check for all the time tolerances. Coming to turbine installation, you have again different configurations for transportation. So you would have the tower in 2 pieces, a bunnier arrangement. So you have two blades along with the rotor and the third blade independent, or you have tower in one piece, the vernier and the third blade, or you have the complete rotor assembled together, the nacelle without the hub, and then the tower in two pieces. So there are various combinations and permutations. You have also the individual blades, the nacelle separate, the tower in single piece or two piece. So different configurations are possible depending on the vessels that we employ. Here are some of the deck configurations for the turbine installation vessel perspective. So if you see here, you have the vernier concept along with the towers and the individual blades. Here you have the complete assembled rotor along with the nacelle and the towers. All these arrangements are depending on the size of the vessel. It's not about the load carrying capacity, but more in terms of the space and the availability of space to accommodate these concepts. So because the deadweight capacity of these vessels is pretty large, so these particular items would not make a dent in that, but it's more in terms of the arrangement and how you arrange it within the restricted space you have. So post the jacket installation, you have your tower being installed. Then you have your nacelle being installed, followed by the turbine blades installed, whether it's one, three, or three separately. It depends on your configuration. Coming to the marine operations and challenges, basically we need to have the vessel transit and accurately position close to 100 200 times in quick succession. So DP system is preferred. If not going for DP, then availability of DP tugs, supply boats, crane barges will become a constraint. Uh, Handling multiple marine spread in close proximity for extended period of time also increases the SIMOPS risk. So these are some of the challenges. Ports have limitations on the maximum beam that they can accommodate. So 45 meters is the maximum some of them can accommodate. Draft must be less than 7.5 meters. So these are some of the challenges when you are looking at selecting the vessel that you want to utilize for your installation. Vessels might not be able to enter ports with bridges because of the cranes that they have. Many of our Indian installation vessels are not capable of transiting the Suez Canal because of the infrastructure in place there. So these kind of things need to be looked at. Wind farm development is not like offshore line because it's more like a production line process. Uh, it's they have to be efficient. You have to keep on rolling out like your assembly line. So you have to simplify the operations, make it as simple as possible. Avoid operations at offshore which take up time, like multiple piles which are welded together at offshore. So single pile, single lift installation to reduce the number of activities and install faster. This also helps you to utilize the weather window and stay a longer period at the site and operate in that sense. People exposure to in a small boats over the side or at height also to be reduced, because again it's more in terms of how you utilize the weather window that you have to install the maximum number of foundations or the turbine. So you look at design aspects where you can increase operational weather window. So using of your dampening systems which are heave compensated, surge sway compensated to increase your operational weather window and stay at a location for a longer period of time. To summarize, I would say that offshore industry is moving towards deeper waters and bigger turbines. The wind turbine installation vessels are required to install higher capacity turbines, moving towards 15 megawatt capacity. There are a lot of shortages in this particular area. Currently, there are very few vessels which are able to handle this type of turbines, and developers are because the rate at which the technology is moving. Earlier, it used to take 10 years to come from a 3 megawatt to a 6 megawatt turbine. Now, within 5 years, we have moved from 6 to 12 megawatts. So the rate at which the turbine sizes are increasing also would put up pressure on the developers because they would like to accommodate the larger sizes also going forward. Similarly, is the case with the substructures and infrastructure because ports, the jacket structures, the monopiles also have to accommodate these larger turbines because they bring down the economics of the offshore wind. In case of these shortages going ahead for a longer period of time, the developments would not move forward at the rate that we expect and leading to increase in the offshore costs, thereby causing issue with respect to meeting our targets of having the capacity. Currently, floating wind platform is in the growth phase. A lot of focus from various countries is and developers is there on this particular concept, and it will form a substantial part of the wind power mix. Also, the industry is looking at the offshore wind as a power source to produce green hydrogen. So to make the whole complete system net zero going forward. So with this, I would like to end my presentation. I tried to put together what I could think of. One of the areas that I could not cover in this was the cable laying vessels, which I could not capture during this particular session, but definitely going ahead would like to do that also. So thank you very much for this opportunity. I thank Jyotishman sir and Ashwini sir for giving me this opportunity to present. Thank you.
Shri, thank you for a very, very absorbing session. Before I request Mr. Ramamurthy to say a few words, I have a couple of burning questions which I'm unable to hold back to answer you, to ask you. Very, very briefly, one of them is maybe a little bit outside the area of the present talk, and one possibly within. So I'm just feeling that in case you have a size of a wind farm, and if you take the average size going ahead of, let us say, 10 megawatts per wind platform, if you take that one, and if the field is generating, let's say, a 1 gigawatt wind platform field, let us say, that would come to 100 platforms to be put together.
Yes, yes.
That is a huge amount of activity, which then justifies your, profile for bad weather operating and a high weather operating window. You're talking about a 50-year wave, and you're talking about a 20-meter highest wave and almost 10-meter significant wave. Normally, offshore construction platforms would be far away in port by the time such wind thing happens.
True.
That I see is a very, very significant part of this. That is one remark. And just wanted to reconfirm that this feeling of maybe 100, 150 platforms in one development, is that the normal number? Something
yes,
like that?
Yes. That's the normal number. Because right now, 1 gigawatt is considered a small farm.
I see. Okay.
You are going for close to 3-5 gigawatt is the norm. So it is.
So if you still stick to an average of 10 or 12 megawatts, you are looking at 300 platforms.
Yes,
Typically, what would be the distance between the platforms? Velvet platforms, we put several nautical miles away from each other. This would be what? Distance?
Distance-wise, these would be close to about half a kilometer.
I see. Okay. Because then you have certain limitations if you want to use anchored vessels, obviously, if you're so close to each other.
Correct.
Sorry, before I hand over, one more burning question I have. Just like you have, for example, if you say fossil fuels and people like countries like Saudi Arabia or Iran or whatever, have got, just an abundance of resources below the ground in terms of oil fields and oil deposits. Is there similarly wind resources? Are there some parts of the world which are, for example, UK has seen a phenomenal amount of wind power development, and so also China. Are they blessed with a huge wind energy resources, or is it only is only a development initiative which is leading them to go ahead?
No, sir. There are areas which have got significant wind energy potential.
Yeah.
India also is one of them. India has also got a huge potential for wind energy across the coast. So there are certain areas. Europe is one. China is one. US is also one of them, where there's a huge wind energy potential.
And so also India?
Yes, yes.
That's good news for us then. With those few, I would like to, Mr. Dasgupta, I see your raised hand, but I would like to just follow protocol and then request, because I've infringed on protocol already, I would request Mr. Ramamurthy to say a few words. Please go ahead, sir.
Yeah, thank you, Chairman. And if can, in fact, if Ashwini Kumar wants to have a question, I have no problem at all. He can do that to continue because he may sometimes forget to take the continuity. Please go ahead.
No. Please, the people are wanting to.
I abide by the chairman's response. So, I'm really honored to be the chief guest, being invited as a chief guest for this particular innovation. And also we are meeting all our people earlier we have met. To see Mr. Ashwini Kumar as the chairman for this session, and also President of INA, Mr. Dasgupta, and of course the speaker, Mr. Shrivardhaan Jois. It is a very nice session, and though he said he has no expertise on that, he totally gave his expertise on this particular one. Offshore is something always is challenging. The challenges, there are many other challenges than what is mentioned there. India is definitely one of the countries which is blessed with good wind resources for our wind farms. India, as you all know, more than 7,500 kilometers of coastline, especially Gujarat and Tamil Nadu are forerunners in putting up these wind farms. India already ranks, I think, fourth in the onshore wind farms. And India also in renewable energy ranks fifth in the solar energy. So renewable energies are coming up very much in India. He mentioned, Mr. Jois mentioned that he's hoping optimism is 85% by 2050. We will have the renewable energy. If not 85%, at least we should hope for 50% of the renewable energy. The offshore wind industry, wind farm industry, will have definitely a competition from onshore as well as from the solar energy as competitors. The cost of offshore wind farm installation is definitely higher, maybe more than 25%, sometimes more than 100%. So it all depends on what size, where it is being put up, and various other factors. And he also mentioned about so many vessels are either converted or built for offshore wind farm installations, construction as well as for turbine installations. And those so many vessels are under construction. As far as I see, India, I don't know how far they are they constructing any other vessels? I don't know. And also India, so far, they are not even put one wind farm offshore, which is in operation, as far as I know. Till last November, the plant, I think, which was supposed to come in Gulf of Combat, 1.1 gigawatt plant, I don't think it's come up so far. Probably Mr. Shrivardhaan can.
No, sir, not yet.
It was supposed to be, it was in the pipeline for the last 4 or 5 hours, the 5 years,
yes,
but it did not take off at all. In fact, the Committee of Energy, the Lok Sabha in 2000, I think 21 or something, they were very, very optimistic that they must increase the renewable energy sources in India. Offshore is an advantage in the sense that the wind directions are predictable, that you have only two directions, either from land to sea or from sea to land, unlike the onshore where wind directions are quite difficult and you don't have that much efficiency of the wind farms. Whereas in offshore, you have efficiency of the wind farms. But the thing again is transporting people. We were only having an IRS, Indian National of Shipping session, only about 1 week back. The question came up, how are you going to transport people to this? There are rules and regulations. That is also one of the challenges which is going to come. Transporting industrial personnel to the field. And one more thing is, offshore wind farms are better off if you have manufacturing facilities of whatever required for the wind turbines available at the ports itself. So in that sense, you will find Gujarat and Tamil Nadu should go ahead with manufacturing facilities. As you know, India supplies a large amount of wind farm equipment to the world. Suzlon as well as Siemens, they are supplying blades. So I think that India has got a good, future in this respect. And India is hoping to put about 30 gigawatt by 2030 and about 140 gigawatt by, I think, 2040, after which Tamil Nadu may give about 35 and Gujarat may give about 35. So 50% will come from them. And other states also should go ahead with that. So India got a good future. And the only thing is how India is going to go ahead with the cost problem. The cost is not easy. That means somebody has to come putting the whatever money required for the cost. It is very important. So that is one of them. Another one is we have actually the wind potential has already been checked. I understand we have an average 15 knots wind in our coast. That is about 7.5 meters per second approximately. And it has been checked by the LiDAR. With the LiDAR, they have checked the average wind positions, and it is checked. But another challenge is the Gulf of Compact tide. Tide is going to be one of the important things where the insulation is going to be there. And India has got a, very long continental shelf where the depth is not high, maybe about 70 meters. So those also, that means you having a floating construction for or floating foundation for the windmill may not be there at all. It will be actually fixed construction ones. I understand the operation vessels, wind turbine installation vessels are not many, though you said there are so many. I understand there are only 16 vessels at present in operation, and about 9 vessels are under construction, which is my last thing when I came to know. I must have improved later. And also, other than the cable laying vessels, we should also look into these SOVs, service operation vessels. They are one of the important things, because service operation vessels are important in the sense that they'll be transporting people up and down. Whereas the same thing may not be there in the case of this WTIVs, because too many people, just like offshore installation, they'll be going together, installing and coming back. Anyhow, it was a wonderful lecture where you have given all your expertise, and it very much we could get inside of the whatever insulation requirements for this offshore wind farms. And I'm very happy, and I wish you all the best, and I compliment you on your expertise. Thank you so much.
Thank you. Thank you very much.
Thank you so much, sir. For a nice overview of what the challenges are for the industry. Truly, I think you touched upon many subjects, including the manufacturing facilities. and of course the overall thing, the economic aspects which drives most of the huge developments what we have seen in UK and in China. That's a very, very big challenge about how these projects will be financially structured, whether it's going to be a public-private participation, in what manner, cost of energies will have to be initially subsidized to a large extent before the industry catches up. These are all very, very major questions. Having said that, I just noticed Mr. Dasgupta putting up his hand a little bit earlier. So, Jyotisman, would you like to ask you a question now before I look at the other questions which are there on the system?
Thank you very much. It was not a question. I just wanted to say that it is not that all the wind farms, all the wind turbines can be installed one against the other. There has to be a particular specific, kind of area, the direction in which.
Yes.
In the wake of the upstream turbine, the next turbine should not get reduced.
Sure. Should not starve of energy.
Don't starve of the wind or get the weak. So it's not that simple. It's quite complicated in terms of installation of the turbines. I just want to mention that. Thank you.
So thanks for that remark. I'm sure there will be a lot of aspects about design and layout of the array of a wind farm.
Yes.
We have some questions which are there. Mr. Palit would like to know, in these, is there a classification society requirement which governs the design of these wind farms and installation tolerances? Maybe, Rajneesh, can you please invite Mr. Palit to come into the session so that he can ask the question directly? Because there are 2 or 3 important questions he has asked, and that would be useful.
Sure, sir. Amir, do we have provision to allow the participants to come in?
So I have added Mr. Palit in the panel. Mr. Palit, if you want to...
Palita, can you please go ahead? Sir, can you please go ahead with your question? Thank you.
You need to unmute, sir.
Can you hear me now?
Yes.
Okay. My question is that number one is there any classification requirement? Number two, which is very important to know, is what happens to the rotors fitted on a single tower, not on jack-up platform, during the cyclonic weather conditions in offshore area. I'm talking of fitted on a single tower, not on jack-up platform. That is my question. Thank you.
Thank you, sir. Thanks for the question. To answer your first question, yes, these vessels are classed. They are DNV class, they are ABS class rules which guide the design of these particular vessels. And currently, most of them are DNV classed to a very large extent. Coming to your second question regarding the rotor which is sitting on the turbine itself during the cyclonic storm, correct?
Yes.
So these platform along with the tower and the blades and the rotor nacelle are designed to account for the environmental condition that area or that particular equipment is subjected to. That's a requirement also, again, as per the...
Mr. Jois, sorry to interrupt. I am talking of a single tower. You have shown in your layout single towers with rotor. When it is on a jack-up platform can move out in cyclonic conditions. But what happens when there is a single tower and there is a turbine? That is my question, sir.
Yes, sir. So it's basically like any single wind turbine, 5 megawatt, 9 megawatt turbine in the harsh environment. That's what you're asking, right? Not on a jack-up rig. It's standing alone in the open sea.
Yes, that's right. That is right. That is my question.
Yeah. So these wind turbines and their components are specifically designed for the different environmental loading conditions, different installation conditions, different transportation conditions. So these rotors which are on top of a single tower, let's say during an installation phase, and you see a 100-year storm condition, that condition is actually taken into consideration during the design of those turbines, during the design of those towers. There are specific analysis in finite element analysis. You have CFD analysis done to check the impact of the environment on the blades, and then through them onto the rotor and then onto the substructure. So it's a complete engineering process which is undertaken to check and design these particular turbines and rotors for withstanding those harsh environments, because you cannot remove them. A jackup or installation vessel can move to a safe haven during a 100-year storm condition, whereas this thing can't move. It is standing there, so it has to be designed to accommodate account for that.
Yeah, thank you. That is. Thank you very much.
Palita, I would assume that the design considerations would be similar to a fixed offshore oil platform, a wellhead platform or a process platform, which would see possibly extremely severe weather conditions in its lifetime. So I would think that it's a similar design considerations would be used, I would think.
Yeah, it will be similar to the buoys.
Yes.
Which are filling up oil from the
yes.
It is similar to that. Yeah. Okay, thank you.
Sri Udayanda has a question. He has two questions actually. Any thoughts, or have you seen any self-installing wind platforms which would do its own installation on itself? And secondly, any thoughts on why the cost per megawatt or gigawatt for floating wind energy is so much higher than an onshore, than a non-floating, facility?
So basically, okay, to answer the first question, with respect to the floating platforms, there are certain concepts which are self-installing. But I have personally not seen any which are done in that manner. You have spar concepts, floating wind platforms, which are spar concepts, which are supposed to be self-installing. So when you reach a site, you ballast them and make them vertical. You float them out in a horizontal condition, and then you make it vertical at site. So there are certain concepts there, but in action, I have not seen. At least in my limited knowledge. Coming to the other question about the cost of floating platform being nearly 4 times that of the fixed platform, it's basically again to do with the scale. Firstly, it is the whole overall development requirement in terms of surveys, in terms of field farm development. Cost at a deeper water levels is higher. So over the overall lifetime, it gets high. And secondly, the individual cost of making a floating platform versus a fixed platform itself is, I think, 1.5 to 2 times more. And we do not have that much of scale as of now. Like as we were discussing, 100 to 200 platforms, 300 platforms is a norm for a fixed or a shallow water fixed platform. Whereas in a floating platform, we have not reached that scale where you can make these floating platforms like a production line, assembly line system, and thereby reducing the cost. So these become like experimental one-off test cases where you have tried a 12 megawatt floating platform or a 15 megawatt floating platform in a very limited area. Whereas fixed platform you are installing by numbers. So that's the reason for the cost being so high in that sense.
There are a few observations from Jois before I invite him to clarify or ask his question. I just have one thought was coming to my mind when you are particularly talking about these floaters or fixed platforms for that matter, installed a little bit deeper into the water. What are the precautions which are taken to keep them clear of shipping channels, lest they become a maritime obstruction and a hazard? Is there any regulation there where the platforms can be installed and where they cannot be installed?
Yes, sir. As JD sir was informing earlier, you have to have a proper study carried out before you undertake this kind of activity. where you identify your shipping lanes, you identify your mammal movement, you identify your migratory bird movement. Because if it is coming in the route of any of those migratory birds going from Arctic to Antarctic or other places, then you are not supposed to be putting those things in that area. Similarly, with shipping routes, you have to take care that they are not in those particular areas in that sense.
I can also imagine that if you have to do a large number of installations with a jack-up vessel, which seems to be the preferred method of installation, then your soil conditions will also be very, very important. Lest you
Yes,
have a crane capacity of 1,400 tons and you pick up something, you have a punch through and you have the jack-up going into the water.
yeah, you
I
have
suppose those would be some serious conditions to be taken into account as well.
that is one of the reasons that you go for that four-legged jack-up rigs, 6-legged jack-up rigs, and you also have high jacking speeds. So you are reducing your time for jacking up and jacking down compared to an oil and gas rig, because you need to move out within a day or two and install the second turbine, third turbine kind of a thing. So your jacking rates are higher. You don't have the luxury of preloading at the rates that we do for oil and gas jackup rigs.
Right, right.
So you need to be faster. So
Yes.
all those aspects come into the design part of it.
Just one observation. I saw in your environmental criteria for design of these vessels, while you had almost 10 meters of significant wave height and maximum weight of 20 meters, you had tidal variation maximum of 0.79 or 0.8, if I recall the number from your presentation.
So it's basically more in terms of a area specific thing.
Yes.
Because I have given it with respect to generic Europeans area, but
Right.
more in terms of as any other oil and gas field or any other area, you have to go into specific site specific data to look into the
Like
design
Mr.
aspects.
Ramamurthy was also remarking, in the Gulf of Combat, you will see 7-8 meters easily.
Correct.
So those would be serious challenges. Can we have Mr. Jois coming into the platform so that he's got certain remarks of clarification and one or two questions. Jois, come in, please.
Good evening, sir. Thank you for getting me involved.
You can come on video also, Mr. Malikel.
I'm actually not in such a
Never mind. Go ahead.
So, because I frankly did expect that I would be having an opportunity to have a quick chat. So apologies for that. So I'll just quickly have a 5-second introduction. I'm a naval architect, and I've been working. I had been working in Europe for the last 4 years, and predominantly in offshore wind development.
Excellent.
So that's a bit of the background why I get a lot of these questions, and I'm able to maybe shed some light into some of them. So one thing I did post as a message was that when I did a study of the average wind speeds that you see in the North Sea, it's highly advantageous because it's around 10 to 10.5 meter per second. And when compared to the average wind speeds that were measured off the coast of Gujarat and off the coast of Tamil Nadu, that was of the order of magnitude of around 8.5 meter per second. And the impact of that is, I think if I remember correctly, the power generation potential is to the cube of the speed of the velocity, speed of the wind.
Yes.
So it makes a huge difference between 8.5 and 10.5.
Yes.
And while we are on the topic of wind speeds, I think one question was also about what happens in cyclonic conditions. So what I've read in the spec sheets is that there is a cutoff speed. For example, it's around 25 meter per second. Beyond that, the rotors, it will be stopped for safety reasons. And this recently happened in the North Sea because last week they had a major storm in the North Sea. I think you would have seen some crazy videos of flight landings in London.
Yes, in London, yes. Just 2-3 days ago.
The same thing happened. So they had to stop the rotors because it was getting a bit too high, the wind speeds. So that's the normal mechanism that is in play, just to answer that question as well.
Yeah, sorry to interrupt. I think they lock it into place. Yes.
Correct. Yeah.
Right.
So it's frankly, if I may just indulge and take another 15 seconds, I'm very happy that there is this discussion ongoing in India. I think it's maybe the first of its kind in India as we speak, because I've never had this. I've never seen a discussion before about offshore wind, because I think this is the first step that you start talking about it, start thinking about the challenges, and then somewhere in the future down the line, we can have some solutions.
Excellent. Just to go on to the next question, which has been asked, Arvind Sagar has a question which is generally addressed to everybody. It says, is there a scope for upgrading existing wind farms, such as increasing the blade sizes? If any such example is there, that would be you would like to see. So, I don't know whether he means onshore or offshore. But is there a room to upgrade a farm by increasing the blade size?
Yeah, I can also answer this one. It is possible, and it has been done. It is regularly done in Europe.
Excellent. You mean in those situations they would change the? I would expect if you have a certain tower that will limit the blade diameter, so you would change the tower itself or including the foundation and go for a higher structure altogether.
I can only say that for certain that it does happen. I can look up specific projects, but I would assume here I would make an assumption that they would check if the foundation allows for upgradation.
Right.
And then based on that determination, make the upgrades. But it has been done, and it is routinely done so in Europe.
I think that you would also need to redesign the entire shafting system and the brakes and the gear system, because that would also have a bearing. I would assume that also would be involved if you have to change the blades. I mean, you would know it better.
Correct. And so if I may make one more point, which is not really connected to installation, but about the wider landscape. So recently, I think some of you would have been aware that Lamprel, they've really invested into production of offshore jackets for renewable wind, renewable energies. And I think just last month, there was this major company in Spain which tied up with Lamprel such that they could lock in their fabrication facilities for a period of 3 years, fully dedicated for producing jackets for offshore wind. So where I'm going with this is, it's not just from a point of view of, let's say, the Indian market, but having dedicated fabrication facilities can definitely cater to markets in Europe itself, because there is a significant shortage of facilities, dedicated facilities. And if you look at certain shipyards in India, like for example, I've worked in Pipavav shipyard quite a while back, and today I think it is on the verge of bankruptcy or already bankrupt. But the fact remains that they have fantastic facilities for fabrication. So if you could repurpose the fantastic facilities on offer at these shipyards, which are not commercially going fantastic right now, it can definitely cater to a wider market that's well beyond India.
Yes, if we recall our earlier conversation about one field development, we are talking about of the order of 200 platforms. And of course, many of them may be monopod piles, because I see that 75 to 80% of the existing wind farms are monopods. But just looking at the trend going ahead for the platforms which are announced or announced for financial closure, you will see that the share of fixed platforms is increasing. I mean, jackets as compared to monopods is increasing, and the monopod share is coming down to 50%, and the tripods or jackets is occupying practically the other 50%. So if you see that, you will find, as Jois was saying, there's an enormous potential for fabrication of these structures as well, within India as well as for supply to other markets. That's another very important aspect. There is an interesting comment from Udayanda. Do you know if any of the existing platforms in the North Sea, or for that matter anywhere else, has been repurposed for serious wind generation? Any typical oil platform converted to wind?
To the best of my knowledge, not such.
Not.
I think because of the large number of platforms which are required for a wind farm, and typically in an offshore field development, you will have one process platform with, let us say, 20 or 25 wellhead platforms, all spaced out 5-6 miles away. But a typical wind farm would have, as we said, 200 platforms all close by together. So from that point of view, perhaps that might not be very feasible.
And also, sir, the substructures of these wind farms are specifically designed to withstand the effects of the rotating blade. These rotating blades have got a specific force that comes onto the substructure, which our process platforms are not designed for. So those are the other aspects also which would be going into when we are repurposing some of these platforms.
So I think we have had an interesting discussion with questions coming up from different areas, including, as we said, the scale of development and all that goes, technical aspects along with it. And the presentation covered most aspects of fabrication, transportation, installation, including transportation philosophies and how that should work out. So let me just check once again, is there any other burning questions which are there? If not, just want to ask Mr. Ramamurthy whether you have any remarks, having looked at so many points which got thrown up in the discussion. Any concluding remarks you have, sir?
I should say that probably something more about Indian perspective could have been better. What exactly India is going to do in the next 50 years? What are things going to come up? What are our energy demands? And how the offshore wind farm is going to participate or take over part of it? How much? That is because today, if I remember, the average Indian consumes about 1,200 units. That is in a year of energy. The units means 1 kilowatt hour is 1 unit. And probably today's consumption is about nearly 4,800. You can say that tera kilowatts, and it is about so much of kilowatts which is being used now. How these are going to be, how much it will be taken up by this offshore wind installation? Is he going to compete so much well with the onshore wind installation because of the costs involved? And what is the future for it? So having done all this, probably a word about future for these offshore installations in India, take into consideration our huge, long coastline, our whatever is the industrials who can afford to put, finances into this, and taking into our own sea, weather conditions, and only considering also, even if you want to consider only Tamil Nadu and Gujarat, how much really you expect by 2050? Will they achieve that 140 gigawatts installation by that time? Just some assumption or some foresight into that will help, because it's about India.
Yeah, I agree. There are, of course, serious challenges into meeting that kind of targets, 140, 150 gigawatts. Of course, that would be a combination of renewable energy, including solar and onshore wind and and everything else, and possibly offshore wind would be one part of that. Or is it 140 gigawatts to come entirely from offshore?
It is
It is
expected
offshore.
40 from offshore. Out of it, 50% will go to Gujarat and Tamil Nadu. Each contributing about 35 gigawatts, approximately.
Very, very serious challenges, because I would say more than technical challenges, also in the area of economics, and whether these projects will be financed through a public-private participation, and what kind of financial guarantees would be given to a regulator, what kind of subsidies would be given to a power generator. These are very, very large questions which will ultimately drive development, I would think.
And this has to be considered at this juncture.
Yes.
Because you are talking committees, Lok Sabha committees, so many other things, National Wind Energy Board, and many, many, many things. But nothing is taking off. If you see, what about the Gulf of Compact one? It is more than 5 years in the pipeline. Nothing has come. As of I know, he confirmed it, Mr. Jois, that it has not taken off so far. Nothing is in operation so far. Though India is fourth in the wind energy on onshore. See, it may be not as much as others. It may be only 40, I think, gigawatts of total, I think, approximately, same as the solar energy. But what is the future for it? How do you see it? And what steps you are taking with the ministry or with others in order to get this particular one fulfilled? Now, one more question somebody asked me last week. What is in future for our shipyards, especially private shipyards? That question was a little bit answered here. I'm very happy that they can start fabricating. I mean, like Japan, when there was a recession, they started fabricating bridges. They started fabricating all other requirements. So maybe they can do that. Maybe 5 minutes of Mr. Shrivardhaan Jois' time to answer these questions.
Yes.
With your permission, Chairman.
No, of course, sir.
Sir, with respect to India, as you have pointed out, the Gujarat Coast project in 2018, EOI was raised by the government, and close to 30-35 developers expressed their interest. But post that, there has been no activity on that particular front. And as you are aware, 2020 happened, and then we are in the COVID situation. So currently, as of now, the status of those particular actions is in terms of interacting with those 35 developers and pushing ahead with a plan in terms of, as Ashwini sir said, to look at the economics of the development, what kind of subsidies the government can give to ensure that the developers are interested in getting into this particular aspect and developing it further. Because currently, with respect to the infrastructure also, we are lacking. We do not have any kind of a production line, assembly line system of building monopiles or jackets, which is one of the requirements if you have to make the cost come down. We are good at building offshore platforms, but not assembly line of platforms. So those are that is one of the aspects. Secondly, with respect to the wind turbines, OEMs, we are having facilities for onshore wind farms, not for offshore wind farms. So again, that is one of the areas which we need to focus on to see if the Siemens, Gamesas, GEs put up plants or have their facilities upgraded to include offshore wind turbines which of huge capacity. Instead of going for a 7 megawatt, 9 megawatt, you go for a 12 megawatt with limited number of turbines, but producing the similar gigawatt power. So those are the kind of thought processes which need to go into the development aspect of it. But as it stands today, it is, yes, we need to start with the government engaging back into that whole process of looking at offshore wind and engaging with those developers who expressed interest for the Gujarat development.
Thank you.
If I may just come in.
Yeah, come.
There has been a publication recently in last year, 2021, I have it with me. It is regarding the roadmap for the wind energy. So if INA allows me to share the screen, I'll just put it on the screen. I'll share it with you, Mr. Ramamurthy.
I have seen it, but anyhow, I like it to
Yeah.
share. Yes. Please go ahead. Yes.
Please go
I
ahead.
know about that publication anyhow. Thank you. But you can share it with all of us. It will be useful for us. Yes.
Yeah, I think this is the one. Well, this is the one, roadmap for getting started. It has been published on 20th July 2021. So it's a fairly reasonably good account, at least initially. We're talking about it now. And what all things are required to be carried out, they're all laid down here. And certain requirements have been projected as to, I mean, the industry hopes to have these kind of areas to be addressed by the powers that be, so that on a long-term basis, it becomes easier for this industry to come up and prosper. So that's the point that I wanted to make. It's really quite a problematic issue, because there are, the engineering aspect of it is quite involved. In fact, the nacelle which is there, that itself, the design itself is quite complicated, and that also needs to be looked at. So that's what I wanted to just touch upon. Thank you. Thank you very much.
I know that the National Institute of Wind Energy is doing a lot of work on that.
Yes, they're doing a lot of work.
Although there is a financial institution which is also going about financing this. Both are there. But only thing is what I want to express, nothing is moving as per what is projected. That is the only thing.
In the UK, they have somehow managed to crack this whole puzzle. And UK is also facing a lot of challenges, including manufacturing resources or including finances or whatever. And today, the operating wind energy, I think, is the largest in the world, is in the UK right now. China is still second or third. Maybe upcoming China will take over, but today UK is the largest. And being a very transparent kind of economy, and everything is open in that country, so it would be very useful to see how they cracked it in terms of government subsidies and in terms of long-term agreements and power purchase agreements, how they managed to crack that. That would be very, very interesting to see as we go ahead. I would expect how they did that. So, of course, the very large development which is coming up in the world is in China, as one would expect. That is, it is coming up. Maybe they will very, very quickly overtake and become the largest producer of wind energy in the world. Maybe by another 10 years, by 2030 or something like that. That's the target. So, with that.
I think there's one question. Mr. Girish Pai has raised a question.
Okay. Let me just take. Here comes Girish Bhau. Here's a question. Is there any chance of wind direction changing due to environmental deterioration and wind farms becoming suddenly less viable? Is that like, have you heard anything in that direction, Sri? You have gone with, a development takes place with a certain condition, and then in the middle of the development or after development and commissioning, there's a change in the environment and suddenly something else happens.
So basically, it's like the wind farm or the wind turbine per se is allowed to change its direction to some extent to adjust to the wind direction. So, but as an overall field area where you have suddenly the wind not been there, that I don't see, not heard happening. But with I would say the changes that we are seeing with the environment and the way we are seeing different factors, the weather changing, the amount of floods that we are seeing, we are not sure what would happen. But right now, I don't think that is that has been observed or that has been seen where a complete area has wind direction has completely changed or changed by a certain amount. But within that area, for, let's say for a period of time, northwesterly winds are there. Post some time it is southwesterly, the wind turbines adjust to accommodate that kind of change.
I was reading somewhere that a combination of onshore wind farm and offshore wind farm is very useful in a particular region because the time in which the wind blows is complementary to each other. You have a lot of wind which is steady and blows during daytime onshore and in the nighttime offshore, or vice versa. I'm not able to recall exactly what, but a combination of both onshore and offshore will will result in wind energy being generated or electricity being generated all 24 hours is what I was reading somewhere interestingly. Any thoughts you have on that? Anything you have read in that?
So most of the time what happens is there's a lot of resistance from people to having these kind of facilities close to the shore or close to the places where they are living. So many of the onshore plus offshore kind of an arrangement would involve people being acceptable and open to that particular kind of area.
Permission of Chair, can I say something on that?
Yes, sir. Yes, sir.
I understand that the offshore winds, normally the energy production is maximum during afternoon time and night time, when the energy demand is high. That's why it's more beneficial.
Yes, yes.
The onshore, it is during the night time, and at that time the energy demand is not much. So offshore is more beneficial in this aspect.
No, that's a very interesting observation. Yes, that's a very interesting observation. So I think we have come to the end of the session, and if there are no more questions and things, I think more or less during this discussion today, we have covered so many aspects and very interesting and lucid technical presentation from Sri, covering aspects of installation as well as the design of the structure and design of the installation vessels and different modes of transportation. And we have covered during our discussions many other aspects, including economics and the layout of the field. I think for speaking for myself, my own perception of this offshore wind energy has increased enormously as a result of today's discussion. And I would possibly say for all of us here, for each one of us, there is a big amount of carry away and learning from today's session. I would like to thank INA very much for this beautiful opportunity, and to Sri for this wonderful lecture today. And once again to Mr. Ramamurthy for joining us today as chief guest. And with that, I would like to hand over to Rajneesh for the concluding session of today's technical session. Come in, Rajneesh, please. Thank you so much.
Thank you, Mr. Kumar. Yeah, quite an enriching session, actually. So I was a little doubtful how it will go, but looking at the very active participation from not only from our panelists, but also from the audience member, it was very enriching discussion. Actually, I got to know a lot about this wind farm installations, offshore wind farm installations. And also the presentation was very lucid in terms that it was very gave a very good bird's view of the bird's eye view of the whole installation. So I could, even though I don't have a background in wind farm installation, I could make out most of the things which were being said. So it was very good, very informative. And I would like to thank Mr. Jois for sharing his views on this matter, and very lucidly and very put in a very nice way. So we move to the end of the session, and I would like to thank the participants to this seminar for giving up their time on a Saturday afternoon for joining in. And of course to Mr. Ashwini Kumar, who has chaired this session very effectively. Thanks to you, sir.
Thank you.
On behalf of INA, I would like to thank Mr. Ramamurthy, who let us be the chief guest for the session, and also shared his view many times. So many thanks for that, sir. Just let me put my phone on mute. Yeah, it rings at the most inopportune times, sir. So sorry about that. And at the end of the session, I would like to thank Mr. Amir, who has stayed in the background, and very graciously he managed to hold the session from the back end, and I could see there were no technical glitches in people joining in, and it was very effectively managed. So thanks, Amir. And if you are there, we would like to see your face. If you can switch on the mic, and then we can appreciate. Switch on your camera, please. Okay, so thanks, Amir. Here he is.
Thank you.
Thanks for hosting it, and thanks for doing all the publication, all the presentations, and all the information slides, and marketing the presentation. So thank you for that. Big cheer of thank you.
Thank you.
Okay, and in the end, I would like to thank the working committee of the INA who made this session possible, and we look for. So we look forward to having more sessions like this, and we look forward to continued support from the industry. So thank you, everybody. And with this, I think we can end the session.
Thank you very much.
Thank you all. Thanks very much.
Thank you for the opportunity. Thank you.
Thanks.
We hold on most of the last Saturday, most of the months, last Saturday of every month, we hold a technical session at about the same time. So please feel free to join us, and you can enjoy these sessions. Many of the sessions are quite interesting. Thank you.